in this problem, again, this problem involves the user resolving the vectors, one along the inclined plane and the other along perpendicular to the inclined plane, and you given the coefficient of kinetic friction. The friction always acts opposite to the direction of the motion. Let's solve this problem. So you have an inclined plane. This is the inclined plane. And then we have a box. Box right there. And this angle is theta. The weight is always downward, which is m times g. And we're going to resolve this weight into the two components. The one perpendicular to the inclined plane, which is mg cosine theta. Remember, if this angle is theta, this angle is also theta. And one along the inclined plane. So this one will be mg sine theta. And it is also asking about, like, this box tends to slide down, and then you have to find out at what acceleration the box would slide down. If the box tends to slide down, and there is a friction acting opposite to the motion, so this friction force acts opposite here, and we're calling this as a kinetic friction, and we just say Fk, that means the kinetic friction, force due to the kinetic friction. And then there is a normal force acting onto this block. This is the normal force N. So we do not need this mg now. Why? Because we already have resolved mg into two components, mg cosine theta and mg sine theta. And you see, the normal force is equal to mg cosine theta. So if I just look at this equation, so there is no motion along the y direction or along perpendicular to the motion. So this mgn must be equal to mg cosine theta, because the block is not moving along the y direction. Okay, in my case, I call this as a y direction perpendicular to the inclined plane. And now total force, and as the box slide down, there will be acceleration. So in this case, we're going to use the Newton's second law of motion, which is equal to F is equal to ma. Always remember, this F is the net force, so I use net. What is the direction of the motion? It is downhill. So all the forces we need to take. First, this force, mg sine theta, minus this friction force, Fk, has to be equal to the mass times acceleration. What is this friction force? Okay, remember, I'm just writing here. The friction force is always equal to mu k times the normal force. And the normal force is given as mg cosine theta. Fk is equal to mu k times mg cosine theta. So just plug this value right there. So this is equal to mg sine theta minus mu k mg cosine theta. This is equal to mass times acceleration. So this mass, and this mass cancels out. So we do not need the mass. So the acceleration would be equal to g sine theta minus mu k g cosine theta. I'm plugging all the values. What's the value of g? This is 9.8. Sine angle is theta is given, which is 39 degree. 39 degree. Mu k value is also given, which is 0.19. 0.19. The g is 9.8. Cosine 39 degree. You just have to use the calculator. Once you use a calculator, the acceleration value you will get is 4.72. 4.72 meter per second squared. So this is your correct answer.